right, so lesson 8, this is the only topic video. As I mentioned in the intro, we aren't going to be working through example problems, especially because we really aren't learning new types of problems in this section. We're just kind of assembling a list of formulas to derive functions that we haven't talked about yet. And as I mentioned, those are the inverse trig functions. So remember, there are 6 trigonometric functions, so we have like sine of x. But if we want to invert that operation, we use the inverse sine, the sign with the little -1. Those functions, we need to have a way to derive them just like any other function. But it, at this point, is just a matter of having the formula. I guess that's the point here that I want to make. So let's move through. I have 3 different screens. There are 3 formulas on each one that I'm going to help you fill out. Make sure that you have them all in your notebook and also that you label them appropriately. So each one of them, I'll tell you what we're talking about. Make sure you label them or else you're going to get confused when you go back to use those notes. So that being said, let's go to the first screen here, which is just a list of the 3 inverse trig functions for which there are derivation formulas. So for instance, in the green, we see d dx, so we're saying, how do we take the derivative with respect to x of the inverse sine of u? And it's kind of interesting at this point because they know, and by they I mean the textbook that we're using, they know that you understand the chain rule. We're going to start listing our derivation rules with the chain rule kind of included. So we couldn't do that at the beginning because you didn't really know what the chain rule was, the idea of having a function within another function. But since the chances of having a function within another function is very high at this point, we might as well just work it into our formula. So we're not writing down the derivation rule for the inverse sine of x, but the derivative with respect to x for the inverse sine of u, some function. And here's what it is. I'm just going to copy it down for you. You write it into your notes. It is 1 over the square root of 1 minus u squared. And here's the part that looks like the chain rule. This is the derivative of the outside function, the sine, the inverse sine part, times the derivative of the inside function, du dx. So if for some reason we were just trying to find the inverse sine of x, that du dx would just be 1, right? It wouldn't. There is no inside function, so we'd ignore it. But let's say we were trying to find the inverse sine of x squared. Well, then u is x squared and du dx is 2x, the derivative of u, right, with respect to x. So it's exactly like the chain rule, but they're working it into the formula because they're making the assumption that more likely than not, you will have an outside and an inside function. All right, that's formula number 1. Formula number 2 is the derivation for the inverse tangent of u, some function with respect to x. And that is 1 over 1 plus u squared du dx. Same line of reasoning. Inside function is the left portion times the derivative of what's inside. Last but not least, the inverse secant function. And this one's kind of fun because it involves the absolute value, which is kind of interesting. So it's 1 over the absolute value of the function, whatever u is, times the square root of u squared minus 1 times the derivative of what's inside, du dx. As you may be noticing, these are not the prettiest formulas, but we need to have them in our toolbox. We need to be able to refer back to them and plug the correct information in because there are times where we're going to need to find the instantaneous rate of change of an inverse function. So that's what these formulas are for. But 2 things you might notice, for the most part, there isn't going to be a lot of simplification after you plug into a formula like this. You know how in other, say, a power function, we might be able to put like terms together, or we might be able to cancel in a using a quotient rule type of situation. You might be able to cancel factors or whatever. There's probably not going to be a lot of cancellation when you have squares and square roots and possibly absolute values and all kinds of crazy stuff. Most of the time, we're just going to be plugging it in, and then maybe there will be a little bit of simplification that's available, depending. But there they are. At face value, that's what we have. Now, we know there are 6 trig functions, which means there are also 6 inverse trig functions. So you'll notice that we're actually missing the formulas for inverse cosine, inverse cotangent, inverse cosecant. And that is because the inverse cosine function is actually just a transformation of the sine function. So the inverse cosine function is actually pi over 2 minus the inverse sine function. So if you have an inverse cosine, you can just rewrite your formula when it's at its, the top level of the derivation ladder, right? When it's at the top level, rewrite it as a sine function, and then you can use the sine rule, right? So rewrite it first, and then you can use the inverse sine, not the sine, but the inverse sine rule for derivation. Same thing with inverse cotangent. I'm actually going to just do it in a different color because I feel like my lines are going to collide here. So the cotangent, the inverse cotangent, is just a transformation of the tangent. It's actually pi over 2 minus the inverse tangent of x. And then last but not least, the cosecant, the inverse cosecant, is pi over 2 minus the inverse secant function. So again, when we're thinking about, we have our little ladder of derivation. We have y, and then we're taking y prime, and we can carry on. We can do y double prime. When it's at this top level, it's still as just a normal function, y equals whatever. Make sure you rewrite that function so that you can derive it. You only have a rule for inverse sine, inverse tangent, inverse secant. But it's okay because you can rewrite cosine, inverse cotangent, inverse cosecant. Rewrite first, derive second. Third little list of formulas is right here. This is because you'll notice on your calculator, you only have inverse sine, inverse cosine, inverse tangent. Sorry about that. That is okay because we also have formulas that will help you to transform your inverse cosine, inverse sine, inverse tangent, other way around. You can rewrite inverse secant to be an inverse cosine function. In fact, it would be the inverse cosine of 1 over x. You can rewrite the inverse cotangent as actually a transformation of tangent, pi over 2 minus inverse tangent of x. And then you can rewrite inverse cosecant as an inverse sine function of 1 over x. You only need to use those if for some reason you need to plug in a value into your calculator and you need a way to rewrite it. So those are your no calculator rewritten, or your no calculator button formulas. So those are the formulas that will allow you to rewrite it so you can actually get a numeric value if you need to. Like, there are many problems where you might not need to figure that out, but if you do, now you have the formulas. Okay, just in review, because I feel like all of these formulas seem kind of similar, so let's make sure we understand how they are different. The first set is the most important. It's your 3 formulas for deriving inverse trigonometric functions. The second list helps you to rewrite the inverse cosine, inverse cotangent, inverse cosecant so that you can use those formulas. So these 2 are very closely related. And then third, this is kind of just an addendum. You want to have it somewhere in your notes in case you need it. But if you need to use your calculator, you need to actually solve to find a numeric answer, or you need to graph it, or whatever, You don't have buttons for these three, inverse secant, inverse cotangent, inverse cosecant, but now you have a way to rewrite that information for whatever reason, whether you're using it in the graph or calculating or whatever. All right, that's it. We're not going to do any extra information because, as you can imagine, I could take that in 10 different directions, but they're all going to come back to all the rules we've been discussing anyway about how to take the derivative, right? Like whether we're using implicit differentiation, whether we're using the chain rule, whether we're applying it to a physics problem or finding the normal line or whatever. So that is that. Make sure it's in your notes, and you can call it a day on lesson 8.